Okay, today we're going to be talking about other objects in our solar system. We're going to break that down into several categories like asteroids and meteors and comets and dwarf planets. So after the sun and planets initially formed, some material didn't get close enough to a larger body, or in some cases, like in the asteroid belt, for example, it got too close to Jupiter and actually was getting pulled apart instead of forming into a planet. So the leftover stuff that wasn't pulled in by gravity and then formed into one of our planets or even our dwarf planets, that material then became some of our other objects in the solar system. Asteroids are the first one of those that we're going to talk about. Asteroids come in all different shapes and sizes. They're different varieties of rock. They're all made of some sort of a rocky material. Asteroids, as with everything in our solar system, orbit the sun. Most asteroids are not spherical. The closest ones to being an actual round object, a sphere, like Sirius, of course, is actually a dwarf planet, but since it rides around in the asteroid belt, it's kind of one of those objects that's kind of a little bit of both. It's an asteroid. It's now been categorized as a dwarf planet. Some of them are really irregularly shaped. Some of them are very, very small. And like I said, in the case of a thing like Ceres, it's actually now quite large, or it is large enough to be called a dwarf planet. Most of the asteroids are located between Mars and Jupiter. Almost all things in our solar system, including the asteroids, formed about 4.6 billion years ago when the solar system initially formed. Okay, we do a lot of studying of asteroids because they tell us a lot about the materials that were in our solar system. It's one of the things, planets go through a lot of changes because of weathering and erosion and storms and things of that nature. Asteroids literally look just like they did 4.6 billion years ago when our solar system first formed. We do have some asteroids that come very close to Earth. Some are even called Earth crossers or Earth grazers, meaning that if we were to cross paths at the same time, we could have a collision. Some of them are called near-Earth asteroids, which means they come close enough to view at times, but won't actually ever hit the Earth. All right, the next thing we're going to talk about are meteors. Now, meteors are kind of interesting in that we're going to use three different names for the same rock. What I mean by that is the location of a meteor is how we name it. Okay. Now, meteors, again, kind of like asteroids, can be all sorts of different shapes and sizes. Some of them start fairly large, and by the time they get through the Earth's atmosphere, they're very small. There's millions of them on the surface of the Earth. A lot of them hit the ocean, and a lot of them are, just hidden out in the woods or who knows where. Some people might have even seen them. You might have picked one up once and not known what it was and thrown it right back on the ground because you just weren't aware that what you picked up was a meteorite. Okay? Now, naming them, again, is location. So if you look at the picture on the slideshow here, you'll see that a meteoroid that ends in OID is out in space. Just think of the word asteroid, and then you'll remember that a meteoroid is when that rock is floating out in space. We then call it a meteor when it crosses into the Earth's atmosphere. Most people would call that a shooting star. Okay? We see a white streak of light going through the sky. That is our atmosphere burning up the meteor. Okay? So the next time you see a white streak of light flash through the sky and you think shooting star, you know that that's a meteor that's getting burnt up in our atmosphere. Now, whatever material remains after the meteor gets through our atmosphere and actually strikes the Earth, now we call that a meteorite, ending in ITE. So if you were to find a meteor, you would not call it a meteor because you're picking it up off the ground. You would term that a meteorite. Okay? You would want to look for something that's probably looks like it's been on fire, because in reality it kind of has, because in going through the Earth's atmosphere there's so much friction and heat that meteorite's going to be black, look charred, have very smooth rounded edges because it's been polished by our atmosphere as it traveled through. They should also be very, very, very dense, because a lot of them have iron in them, and again have a real high density. Okay, so that's kind of what you might be looking for. Okay, now the next big meteor shower that we'll be able to see is called the Lyrid meteor shower, and that should be sometime between April 16th and 25th. Okay, otherwise you'd have to wait till next August sometime. All right, comets are the third thing we're going to talk about here. Comets are kind of cool because when they pass near enough to Earth, they look a little bit like the one in the picture, because when they get close to Earth, they form a tail, and you can see those from space. So what a comet is a great big icy snowball. Like if you were to take a bunch of snow and add a bunch of rocks and ice and those materials and pack it together, you'd have the basics of a comet. So they are called a large, dirty snowball. They have ice and dust and rock and gas and everything all frozen together into a big chunk. And when they're out deep in space, they're really hard to see because they're dark and they do not give off any light. Now, when they get closer to the sun, they're a little easier to see. Okay? The reason for that is the outer layers of the ice and gas and dust, all that frozen material, gets vaporized by the sun's heat. Then, because of that vaporization, they appear to glow, when really we know that that's just the sunlight reflecting off of the vaporized gas and ice. Okay? We know that the only thing that gives off light in our solar system is the sun. Everything else we see is a reflection. Okay, so the comets are no different. All right, so when that begins to glow, give off light, reflect light from the sun, right? We call that the coma, because now you'll be able to see what kind of looks like this glowing ball of gas. Okay. Then as it comes even closer to the sun, the solar wind will move across the comet, kind of blow across the comet. All the particles that are streaming off of the sun will move across the coma and push those vaporized gases and the dust out behind the comet. Okay? So, if we look in the next picture, one of the things that you can tell on a comet, in terms of if you wanted to see where it was in its path, you always know this rule. A comet's tail always points away from the sun. The reason for that is the tail is formed because of, again, the solar wind. It's the particles of the sun moving across the comet. Okay, it's not like a tail you might think of when you look up in the sky and see a jet flying through the sky, or maybe you see a picture or watch a horse run, it's got the tail moving out behind it. It's not like that, because remember, we're in space. And there's no atmosphere, there's no air molecules, there's none of that stuff to form a tail. There's no air resistance in space. Space is a vacuum. Okay, there's nothing up there. So, that being said, the comet's tail is formed from those particles and therefore always points away from the sun, as you can see in the picture. Now, the last slide I have on comets talks just a little bit about their location. We talked about this when we were out on the football field. We know that the two places comets are located are either in the Kuiper Belt, which is out just beyond Pluto's orbit. Pluto kind of is the beginning of the Kuiper Belt, and then it moves out past Pluto. In that belt is what we call short-term comets. And short-term comets we might actually have a chance to see. Maybe you think of like Halley's Comet or Hale-Bopp comet that come by maybe, let's say, every 50 to 75 years or something like that, sometimes a little longer. Those are the comets that are in the Kuiper Belt. We have a chance, you should in your lifetime get to see Halley's Comet, for example. Okay, the other comets lie way out there in the Oort cloud, which is the spherical cloud that wraps all the way around the solar system. Those comets take a long time to go around the sun. Even some of them take as long as 1,000 years. All right, the last thing here we're going to talk about are dwarf planets. Dwarf planets are kind of new. When I went to school, there were no dwarf planets. Pluto was just one of the planets, and we didn't really know about dwarf planets. So as we've discovered more about our solar system, we find a lot more objects out there. So therefore, there was kind of a need to discuss what is a planet and what isn't a planet. There's a lot of debate on this. There are scientists that would just argue that they're all planets. Pluto is a planet, Eris is a planet, Sirius is a planet, they're all planets. And then there are other people that want to have some rules to what makes a planet a planet. So they came up with 4 kind of rules. Okay, it has to orbit a star. Well, all dwarf planets, all planets orbit the sun. It has to be big enough that gravity made it round. So that eliminated some planets right there. Pluto is round though. Has to be small enough that it isn't a star itself. Well, that's all planets. Even Jupiter, Jupiter's pretty big, not big enough to be a star. And the 4th one is that it has to have cleared the area of smaller objects. That's where Pluto didn't make it. Okay, Pluto has a lot of debris in its orbital path. Okay, if you were to look at Earth's path, if we were to be able to track Earth's path around the sun, there would be little to no debris. There wouldn't be any rocks or any of that kind of stuff in our path because years ago, 4.5 billion, 4.6 billion years ago, Earth was able to pull all that stuff into it and there's nothing left. Okay, so that's kind of why Pluto got the boot, because it had not cleared its orbital path. Even though it orbits the sun and it's round and it meets some of the other characteristics, it did not clear its path when the solar system formed. These are the known dwarf planets. The picture on the far left is our moon. Okay, so the picture is kind of designed to give you an idea of how big the dwarf planets in our solar system are compared to the moon. So you can see Eris and Pluto are very similar in size, and then you have Haumea, Makemake, and Sirius as the next 3. So that's just kind of an image of, the 5 that we know about and their comparative sizes. Okay, you should have everything on your note sheet filled out at this point. If you missed anything, just kind of slide back to the beginning and see what you missed.